So today we are going to be talking about chapter 6. Most importantly, it is over z-scores and the normal distribution. However, before we get into z-scores and normal distribution, we have to consider what z-scores and normal distribution applies to. So if z-scores and normal distribution, if you were to have a very skewed plot graph, so let's say if the graph of salaries tend to be very skewed. Most people tend to make around here, and then as you go up, we're getting close to our more and less people, and probably all the way down here, you're gonna have Jeff Bezos, right? So this graph, being a very skewed graph, will not work well for the normal distribution and our z-scores. It does not apply. So we can't use it this way. So today we're just gonna do a review of for those graphs that cannot apply to our z-scores normal distribution, which is our skewed graph. So let's think about a different type of skewed graph. Let's talk about, for example, if we were to say we are at a zoo, okay, and the median numbers per exhibit. There's multiple exhibit types at the zoos, right? You got your big cats, your bears, your reptile house, your insectarium, all different types, and they took account on the number of animals on each different type of exhibit. And it came out to be like this. Let's say down here, let's say for our first number, the lowest number, let's say that one is 10. The lowest number, we'll just say this, okay, this could be our bears. Bears are big, take up a lot of space, and they're hard to come by. So maybe there's only 10 bears total in the bear exhibit. And then here would be, in our box plot, would be our other animals, would be our most average animals. Let's say here the next would be 20, and then let's say then the most that let's say the insectarium, they actually counted how many insects there are, and there were about, like, let's say there were 200 insects in the insectarium, and then they give you the median, which is about 40. And then they only give you the interquartile range, so the IQR interquartile range. The interquartile range is just a fancy way of saying this distance right here. And they say the interquartile range is, let's say, 50. It's 50. So since the interquartile range is 50, that means from 20 to whatever number, there has to be 50. So that makes this number over here, 70? And that is how we would estimate that. Now let's say this would given is our Q, this is Q2, so this would be Q2. This is our third quartile. This is our fourth quartile, or the highest number. This is our very first quartile, and this is, our minimum, the smallest number. And let's say our standard deviation is 30, and our mean Let's say that is, we'll just say 50 here. So what happens to, let's say we got a generous donor, and this donor wants to donate animals, and let's say he gives or she gives the zoo a choice. Let's say the first choice is the zoo gets 2 more animals uh, per exhibit. Well, what does that mean if they give 2 more animals? For example, does that mean for all of our numbers? Well, that means our minimum will be 12. Our Q1 will then shift over 2, so that would be 22. Our Q2 or median would be 42. Our Q3 would then be what will shift over to, that would be 72. And our Q4 would be what, 202. In terms of our standard deviation, however, so our mean, let's look at our mean first. Our mean will shift over 2. Since all the numbers shifted 2 equally, our standard deviation actually will not shift over. It will actually be the same because all the numbers shifted equally. Now let's say the other choice is of this donor, they want to give a 10% increase. So you get a choice between whether or not you get 2 more animals or you get a 10% increase in your animals. So this makes, so let's say here our minimum, we have to then multiply everything by 110%, so 1.1. So our minimum becomes, let's see here, 10 times 1.1 is 11. Our Q1 becomes 20 times, we have to multiply everything by 1.1, so 20 becomes 1.1. This becomes 22. Our Q2 becomes 40 times 1.1. This becomes 44. Our Q3 becomes 20 times 1.1 becomes 77 animals. Our Q, as you can see, this 10% starts to grow more as we get more animals. It becomes 220. Our mean then times 1.1 becomes 55. This is our mean. And then our standard deviation then also grows because it's less on one end and greater than on the other end. It also changes by 10%. So we take our standard deviation of 30, times that by 1.1. Our standard deviation becomes 33. Finally, if someone were to say, oh, well, what is the range of numbers of animals? Let's look to the original amount of animals that falls within the 50% of animals that are actually in there. Well, that range would then be 20 to 70. It lies within the most, with the 50% in the central amount of animals, average amount of animals that the zoo has. And that is the first portion of chapter 6 and Z distribution normal plots.